Hello and welcome to another devlog for Project Orthros. In this one I'm concentrating on making the game more interactive. To do this I will need to do two things. First I need to create some sort of rudimentary UI that the player can interact with. Secondly I need to create some data structures which contain information about the player and the game units. As a concrete example I use unit spawning, which I want to make easy on the part of the game which is requesting a unit to be spawned. Since I will now start incorporating terminology which is directly connected to the world that the game will take place in, I will first give an overview of what my vision for the story or alternate world is. Speaking of terminology, I will also give a short overview about the entity component system used in Bevy, since I will use some jargon which might not be so easily understood if you don't know about that. Let's start with the alternate world the game will be set in. This is not yet fully developed and will likely change over the course of the development. Anyway, here are the rough ideas floating through my head. I want to imagine a world where ancient civilizations like the classical Greeks, Romans, etc. survived more similarly to what they were at the time. For example, what if Athens had not become a vassal of Macedonia and later a state in the Roman Empire? What if the Roman Empire had simply not fallen? I will likely not concentrate only on the European continent, but will try similar extrapolations for other civilizations, like for example some American civilizations, some Asian civilizations. This theme will likely influence everything from visuals like decorations, the units, the buildings, to the gameplay, the tactics, as well as story and missions. I will likely not be correct on every historical aspect, even though I will make an effort to make it somewhat historically accurate and believable. One major aspect I have not yet decided on is whether or not to give the game a mythical component. If so, it would have a similar pantheon as, for example, Age of Mythology, where all the gods are somehow represented and maybe even at strife with each other. At the moment, though, I'm leaning toward leaving out this supernatural aspect of things. What I will definitely try is to have some more realistic gameplay components in regards to, for example, propulsion, lightspeed weapons on a solar system-wide scale, and the tactics that result from that. With this, I want to avoid just creating an Age of Empires in space of sorts. If you have any thoughts about this, leave a comment down below and tell what you would like to see from this game and why. In this devlog I will go more into depth on some concrete implementations. It might be helpful if you know something about entity component systems, but I will try to give a short overview of what it is and how it is implemented in Bevy. Let's start with the name Entity Component System. First of all, there are obviously the entities. These are basically just IDs that are attached to a group of components. Components contain information about a certain entity. These are realized as either structs or enums. We can have, for example, an entity that represents our starship with the aptly named component starship. This means we can search and select all entities that have the component starship attached and mutate them if we want. It will have parameters for its position in space, for example, or its mesh, but they rarely, if ever, contain any actual logic. This falls to the systems. A system is a function that runs at every game tick and manipulates the components and by extension its entities. If we want to move, for example, our starship, this is done by a system. To access our components, we use so-called queries. If, for example, we want to move all units, we have to query for all entities with the starship component. This returns an iterator of all the matching entities. Each element of the iterator can then be mutated. Bevy expands this by having two more important concepts: resources and events. Resources allow unique global data. While we could do this using just one instance of a component, it is easier to access resources. Events are basically short-lived entities which self-destroy upon reading. They can be used to communicate between two or more systems. Again, this can be done, and in some instances I do it using components, but they make some things easier than if you would just do them manually using components and entities. If you want to know more about ECS, you can have a look at the Bevy Book or the unofficial version linked in the description below. Now let's get to the UI work that I've done. I must say that I have very little real-world experience building UIs. This is why I will shamelessly adapt one of the better UI designs I've come across in strategy games, the one from Star Wars Galactic Battlegrounds. If this means nothing to you, you might know a similar layout from Age of Empires 1 and 2. Both Age of Empires 2 and Galactic Battlegrounds use the same game engine and are from roughly the same time. Their layout is rather simple. Age of Empires has a top and bottom bar, Galactic Battlegrounds only the lower one. In the top bar you see resources, etc. and some pop-out menus. Fun thing is that Galactic Battlegrounds actually moves the buttons from the game menu, trade, etc. as well as resources to the bottom right above the map and besides the map. Maybe I will have to rethink this whole thing. The bottom is cut into 3, not looking at you, Galactic Battlegrounds, segments. The left side contains the actions you can perform with whatever you have selected. The center contains information on your unit and a portrait. The right contains a map with different modes, and in Galactic Battlegrounds the Idle Villager button. Here the Galactic Battleground UI redeems itself fully in my opinion, because when there are Idle Villager, the button does this. Okay, so now we're stealing those concepts. Bevy's UI system is at the moment still a bit difficult, at least for me. It uses a Flexbox model, and since I'm no web developer or UI developer, I've literally no idea what I'm doing. But somehow I got at least the basic UI working. When a UI element is spawned, it is initially parented to the root, meaning it will just appear according to the rules of the root node. To partition this green, we have to write style rules and use the Bevy hierarchy system. A Bevy entity can have a parent and arbitrarily many children. UI nodes follow this parenting, meaning if I have, for example, a parent node which takes half of the screen and create a child with 50% width, this will be in relation to the parent node. I use this to partition the screen according to what I wanted. Next I got the map working. At the moment this is just its own camera pointed on the map. And as you can see, this looks pretty bad. First of all, we don't need the grid in this view. The renderer can't render it properly anyway. Bevy's camera system allows you to define different render layers. This means I can define what is rendered on which camera. So I can, for example, have the grid in its own render layer and not displayed in the map view. Next, I want the ships to be a bit more clearly visible on screen. For this, I create a large colored plane for each of them, which can only be seen by the minimap camera. Again, I have to use render layers to avoid having my view cluttered, but this time in regards to the main camera. After adding another layer, which is strictly for the minimap, the view in the main port is again free. I'm sure that using a second camera is not the best approach for all of this. Firstly, I insert further entities which are strictly speaking not needed, and it forces me to define anything I want rendered in the minimap explicitly at spawn time. But for the moment it gets a point across, which I think is more important. I might change this in a later iteration to maybe generate a texture from the positions of everything. Now we come to the next section, the center. It is only populated when selecting a unit, or maybe later an interactive element of the game, such as a resource, an anomaly, or something of the sort. Any unit gets a component containing information about the unit when spawned, also used for other purposes later. This information is used to construct a short unit text and spawn a thumbnail beside it. And here you can see the information panel in action. The left side is populated with actions specific to the unit selected. These actions are encoded in a resource resource pertaining to the specific player, called player info. Every unit has a set of context menu actions associated with it. These get updated when, for example, new technologies get developed. I've used the system to allow me to spawn units from the space station. Afterwards I added some decorations to the UI, which went very well, as you can see. All joking aside, I got it working in the end. The trick is to separate the content of the UI from the decorations and spawning it behind the content. As you can see, I tried to evoke some sort of modernized version of commonly used Greek or Roman stylizations. So now that the UI is working for now, I had to implement spawning of new units. You have already seen that in the last part, but now we come to the actual implementation. Until now I've been creating them manually in the main.rs, which is fine for prototyping, but has some obvious and some not so obvious problems, like having to state the fire path in all locations where I want to spawn a unit, having to change it in every place if I ever dare to change the name. The other thing is that I need to modify the material because Bevy does not support some extensions in the 3D file format that I use. These are used, for example, to allow greater emissiveness of materials. Here you can see the comparison on the left, the one without the greater emissiveness, and on the right the one with the somewhat more accurate emissiveness. So I'd like to have one central location where I spawn units. For this I created a system running in the background which listens to instant spawn request events, which are structs which contain information about the requested unit, namely position, type and civilizations. This should be all the information the system requesting the spawning has to know. Further information is globally contained in the unit specification. Here we have some crucial things like the actual file path of the 3D model, the icon path and more, which are really important for the spawner to know, but not relevant for the part that is requesting the unit. To be able to access the specifications globally, we have a global resource called Unit Specifications, containing a hash map indexing the specifications by unit type and civilization. Now if some part of the program wants to spawn a unit, it just needs to send a spawn event and it will be spawned. This you have already seen in the previous part, where I used it to demonstrate the spawning of units in the space station. I can also spawn larger numbers of starships now, as you can see. This luckily in no way leads to any problems. So this concludes this devlog. Next I'll maybe work on getting a second player in locally, like a very primitive AI, and implementing some simple fighting mechanics. Or maybe I'll work on economy, like resource gathering and integration into the UI. If you're interested in the game, leave a comment down below with suggestions in regards to gameplay and maybe story. Thanks for watching, bye!